Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, paper 2, variant 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 part A says table 1.1 lists some SI quantities. Complete the table by indicating with a tick which rows are SI base quantities. So first of all we need to understand there are 7 SI base quantities and 7 SI base units. First of all, time is SI base quantity and its unit is second. Length is SI base quantity and its SI unit is meter. Mass is SI base quantity and its SI unit is kilogram. Current is SI base quantity and its unit is ampere. Temperature is SI base quantity and its unit SI unit. SI unit is Kelvin. Amount of substance is SI base quantity and its unit is mole. Luminous intensity is SI base quantity and its unit is candela, CD. So these 7 SI base quantities and 7 SI base units you need to understand. So if you look at given table, current, this is SI base quantity, energy is derived quantity, force is also derived quantity, and mass is SI base quantity. So this is simply you have to take current and mass. Part B says use the definition of power to determine its SI base units. So power, simply hint is given to you, use the definition of power, and power is equal to work done over time taken, means rate of doing work. So simply we can say work done over time taken. So this is how you can write down, and work is equal to Ft. So this is force time displacement in direction of force divided by time taken, and F we can write on F is equal to ma. So this is times d divided by time. Now simply we need to write on the units. Unit of mass is kg, unit of acceleration is meter per second square, and unit of distance is meter, and unit of time is second. We can simplify this one. We can say this is kg, and here we have meter square and s to the power of minus 3. So this is SI base unit. So we can write down this is kg meter square s to the power of minus 3. So these are SI base units of power. Part C says a light meter is used to measure the intensity of light in a classroom. Daylight is incident normally on the sensor of the meter. Normally, it means that this one is the area and the light is incident like this. So the angle between them is 90 degrees. The sensor has an area of 2.2 centimeters square. The reading on the meter is 950 watts per square meter. Calculate the power of the daylight incident on the sensor. So simply we need to understand for this one, intensity is equal to power over area. We need to find power, so simply power will be equal to intensity times area. Intensity times area. And value of intensity is given to us, that is 950 watts per square meter. So this is value of intensity, and area is given to us in centimeter square. So we need to understand 1 centimeter, this is equal to 10 to minus 2 meters, and 1 centimeter square, this will be equal to square of this. It means this will be equal to 10 to minus 4 meter square. So simply we have to replace now centimeter square with 10 to minus 4 meters square, and this is, of course, this is multiplied. Now if we solve this one, we will get in this case 0.21 watts. So this is the final answer, and given data is this has 2SF, this also has 2SF, so the final answer should have 2SF. So this is our final answer. Question 2 part A says define acceleration. Acceleration simply is equal to delta v by delta t. So simply this is rate of change of velocity. So we can say acceleration is rate of change of velocity. So this is how you can define acceleration. Part B says an Olympic diver stands on a platform above a pool of water as shown in figure 2.1. When the diver is on the platform, its center of gravity is a vertical height of 9.0 meters above the surface of the water. The diver jumps from the platform with a velocity of 5.9 meters per second at an angle of 60 degrees to the horizontal. Air resistance is negligible. When the diver hits the surface of the water, his center of gravity is a vertical height of 1.2 meters above the surface of the water. Calculate the speed of the diver at the instant when he hits the surface of the water. So for this one, first thing we need to understand the center of gravity of the diver. The change in position of center of gravity of the diver is the difference between, we can simply say delta H, this is equal to 9.0 meters minus 1.2 meters. So the decrease in height of center of gravity is equal to 7.8. We can also define a reference point. So at this position we can define GPE, gravitational potential energy, this is equal to 0. So now simply we can use conservation of mechanical energy. So we can say kinetic energy initial plus GPE initial. GP initial, this has to be equal to kinetic energy final plus GPE final. So GPE final. So we have GPE final, this is equal to 0, and we can write down kinetic energy final, this will be equal to kinetic energy initial plus GPE initial minus GPE final. GP final, but GP final is equal to 0 because we have defined this is reference level and GPE at this point is equal to 0. So in order to calculate kinetic energy, means the speed of the diver, the final speed, we can say 1/2 mv square. This has to be equal to 1/2 mu square plus mg delta h, or we can say initial height. So mass we can cancel, it is not depending on the mass, so we can write down v square. If we multiply both sides by 2, we can say v square will be equal to u square plus 2g times delta h. So value of u we have, that is given to us 5.9, so simply you can plug in here. So this is 5.9 square plus we have 2, and value of g is 9.81 and the height is 7.8. So this is the height. And now if we solve this one, we will get value of v, that will be equal to 14 meters per second. So this is value of v. So this is how you can calculate. So conservation of energy for this question is very helpful. You can also use kinematics concepts, but conservation of mechanical energy is the best tool for this question. I hope this question helped. If you have any questions about this one, if any point is still not clear after this explanation, please leave your questions in comments and I will try to answer as soon as possible. Part C says the diver in B enters the water and decelerates. Describe and explain the variation of the viscous drag force acting on the diver in the water as he moves downwards. In the question, the first thing you need to understand, it is given to you, it decelerates, mean the speed decreases. So simply we can say speed go down. Now we need to understand the drag force, or simply you can say drag, this is equal to 1/2 rho a v square. This formula you don't need for A level, but simply you need to understand drag force is proportional to v square. So if v go down, it means drag force will go down. So this is what you need to understand. So how we can write down the answer? For the answer of this question, simply you can say as diver moves down, his speed, so you can say his, or there you can say his speed decreases, so drag force decreases. If you write on these 2 points, you will get 2 marks. Second part says the diver has a volume of 7.5 times 10 to minus 2 meter cube. The density of the water is 1.0 times 10 to 3 kgs per cubic meter. Show that the upthrust acting on the diver when he is underwater is 740 newtons when he is fully submerged inside water. So this is very important, when he is fully submerged in water. So how we can calculate upthrust? So simply we can say upthrust in this case will be equal to mass of the fluid displaced times g, means simply is equal to weight of fluid displaced. And weight of fluid displaced means the mass we can write down. This will be equal to density of the fluid times volume of the fluid displaced times g. Density of water we have, that is equal to 1.0 times 10 to 3 kgs per cubic meter, and volume of fluid displaced. In this case, this diver is fully inside water, so volume of fluid displaced is equal to volume of person, volume of diver. And volume of diver we have, that is equal to 7.5 times 10 to minus 2 times value of g, that is equal to 9.81. Now if we solve this one, we will get our final answer 740 newtons. So this is final answer. This has 2 SF, this also has 2 SF, so the final answer should have 2 SF. So this is our final answer. Third part says at a particular instant when the diver is underwater, his horizontal velocity is 0. The viscous drag force acting on him at this instant is 950 vertically upwards. The diver has mass of 78 kgs. Determine the magnitude and direction of the acceleration of the diver. So first thing to do for this question is sketch the free body diagram. When the diver is moving downward, the force acting on the diver in downward direction is mg, and there is a force on diver due to the fluid, that is the upthrust, and upthrust is acting in upward direction, and also there is a drag force on the diver, so we can say this one is drag force, and diver is falling down, so this is direction of velocity of diver. So in this case we can write down F net, this has to be equal to drag force plus upthrust minus mg. So this is F net. We need to find out value of acceleration, so we can say F net will be equal to ma, and this will be equal to d plus u minus mg. We need to find out value of a, so this will be equal to simply d plus u minus mg divided by m. So value of d we have, that is equal to 925. Then we have value of upthrust, that is equal to 740, and minus we have mg. M is 78, g is 9.81, and this is divided by 78. So if we solve this one, we will get 12 meters per second per second. And this is value of acceleration. As the sensor is positive, it means acceleration is in upward direction, because we have taken upward positive, and the final answer is also positive. It means net force is in upward direction. So simply we can say value of acceleration is 12 meters per second, and direction is vertically upwards. So we can say direction is vertically upwards. So this is how you can answer. Nice question. So you need to understand how to use F is equal to ma. F is equal to ma is a very important formula in mechanics, especially when you're solving questions based on forces and kinematics concept. I hope this video was helpful, and if this video was helpful, and also other videos on channel, if those videos are also helping you, please like and subscribe, because your encouragement is very important. With your encouragement, I'll be able to spare more time, and I'll be making more and more videos for you to help for your exam preparation. And also, if you're looking for extra resources, please join Patreon. On Patreon, you will see a lot of exam focused resources, not only for physics but also for other subjects. That's all for today's video, and I'll be uploading solution of remaining questions as soon as possible. And also, if you have any questions, please leave your questions in comments and I will try to answer as soon as possible.